This is the spiral review for spiral number 7 for pre-calc. If we start by looking at our first problem, we've got f of x equals negative 6 times the quantity of x plus 5 squared. A couple things you need to know. You need to know that the mother function for this is a parabola, and that different pieces of this equation do different things to the graph. The first thing, in the parentheses, we are moving to the left or to the right. For plus 5, we're going to move 5 units to the left. Whatever number's outside the parentheses being multiplied by this is kind of like our slope. And what we're going to do is look at this negative 6, which is going to mean that this is a pretty steep negative slope. Our parabola is going to open down and be pretty steep. In fact, it's going to go over 1 and down 6. If you list some of these points, so negative 5, 0, you could also do negative 4, negative 6. You're going to get full credit for this problem. Okay? Next, you're being asked to identify an equation for a mother function. The first thing you need to do is figure out what type of function this is. And hopefully at this point we know that any graph that looks like a V is going to have to do with the absolute value of x. First thing I might want to take a look at is where this vertex is. Here it's moving back 1 and up 1. That's going to change our function to the absolute value of x plus 1 with another plus 1 on the outside. The plus 1 on the inside tells me where my x is. The plus 1 on the outside tells me where my y is. The next thing I can take a look at is the slope of this graph. And here I'm going down 1, 2, 3, 4, and over 1. That means we're going to have a slope of negative 4. So my equation is negative 4 times the absolute value of x plus 1 with another plus 1 on the outside. Moving on to our next category. We're dealing with factoring expressions. For factoring my first expression, I'm going to look for things that each of these have in common. First thing I'm going to look at is the two numbers. 27 and 15 are both multiples of 3, so I'm probably going to put a 3 out in front. Then I'm going to look at my x's. I've got an x to the 5th and an x squared. The most they have in common is an x squared. Then I'm going to look at my y's. I've got a y squared and a y to the 5th. They only have a y squared in common. Then I'm going to look at my z's. I've got a z and a z to the 6th. They only have one z in common. Inside the parentheses, I'm going to put whatever's left after I factor out 3x squared y squared z. If I factor a 3 out of 27, I've got 9. If I factor an x squared out of x to the 5th, I've got x cubed. If I factor a y squared out of y squared, there's nothing left. And a z out of a z, I have nothing left there either. For my second term, factoring a 3 out of 15 gives me 5. Factoring an x squared out of x squared, nothing left. A y squared out of y to the 5th Leaves me with y to the third. And a z out of z to the sixth means I've got a z to the fifth. That's all you can do. Nothing else. You're done at that point. Factoring a quadratic. The first thing that we did was take my coefficient for the leading term and my number and multiply them. In this case, I got 9 times 8, which is 72. So I was looking for numbers that multiply to 72 and add up to 17. That happens to be 9 and 8. Okay, I'm going to factor by grouping for this, but again, you can use whatever method that works for you as far as factoring goes. I'm going to write this as 9x squared plus 9x plus 8x plus 8. All I did was split up that 17 into 9 and 8. My first two pieces I can factor a 9x out. 9x times x plus 1. My second two pieces I can factor an 8 out. 8 times x plus 1. Now you might notice that each of these has an x plus 1 in common. So I can bring an x plus 1 out to the front, and the stuff that I'm left with is 9x plus 8. When you're asked to factor, that's as far as you go. You don't need to find anything that x equals. You just need to tell me what to multiply to get your original expression. If you factor by the box method, you need to include the parentheses to get credit for this. It's not enough to just list the answers in the box format. You need to include the parentheses. In other words, if we're looking at the sides of the box, 9x, 8, and x and 1, that helps you get to the answer. That is not the factored form of this. You need the x plus 1 and 9x plus 8. Moving on to solving an equation, there's a typo in this problem. It should be 3x squared plus 21 equals 16x. The first thing you need to do is bring everything over to the same side and put it in order of decreasing degree. So 3x squared minus 16x plus 21 equals 0. I'm going to multiply my a times c. 3 times 21 is 63. I'm looking for things that multiply to 63, add up to negative 16. Only things that I know off the top of my head that multiply to 63 are 9 and 7. Hey, negative 9 plus negative 7 happens to go to negative 16. 3x squared minus 9x minus 7x plus 21 equals 0. Pull out a 3x, and I've got an x minus 3. Pull out a minus 7, and I've got an x minus 3. That's going to mean that x minus 3 equals 0, and 3x minus 7 equals 0. If I ask you to solve, you need to tell me what x could equal to make it true. In this case, that's going to be x equals 3 and x equals 7/3. Any method that you use should get you to the same answer. It doesn't matter if you use the box method, if you use the x factor, or anything like that. Okay? Moving on. Dealing with complex numbers. Generally, I'm going to treat these like I would treat anything else and just solve for x. In other words, get x by itself. If I've got 12x squared plus 75 equals 0, minus 75 to both sides, that's going to give me 12x squared equals negative 75. Divide both sides by 12, and I get x squared. This can reduce. Both are divisible by 3. Negative 25 over 4. When I take the square root of both sides, I end up with x equals plus or minus. The square root of 25 is 5. The square root of 4 is 2. Because it's a negative square root, I need an I. Continuing with complex numbers, I ask you to simplify a complex number expression. Generally, again, we treat these just like we treat binomials. So 4 times 4, I get 16. 4 times 13i, I get 52i. Negative 13 times 4, I've got negative 52i. Negative 13 times 13i, I get plus 169i squared. My middle terms cancel out. I squared equals negative 1. 13 times 13 is 169. Thank you. Negative. So 16 minus 169. I squared is negative 1. 16 plus 169 is going to be 185.
How did you get negative 1?
I squared is negative 1. Here's a screenshot you can use of the first page. Our next problem asks us to complete the square. To do that, we're going to take our middle term, our x coefficient, divide it by 2, and square it. 24 divided by 2 is 12. 12 squared is 144. 144 is the number I really wish I had here. Instead, I have negative 25. How do I get from negative 25 to 144? I have to add something. The something that I'm going to add is 169. If I add it to the left, I have to add it to the right. So x squared plus 24x, negative 25 plus 169 is 144. My right side, I've got 169. The left side factors into x plus 12 times x plus 12, which we know is x plus 12 quantity squared. To get rid of a squared, I can take the square root of both sides. I'm going to have a result that's x plus 12 equals plus or minus 13. That gives us two equations to solve. X plus 12 equals 13, and x plus 12 equals negative 13. So x is going to be 1, or x is going to be negative 25. For tomorrow, you need to be able to write the quadratic formula. It's only worth 1 point, and if you don't know it, you're welcome to come to me and I will write it for you for the cost of that 1 point. Next week, it'll be worth 2 points. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is going to be true for quadratics of the form ax squared plus bx plus c equals 0. In the case of our quadratic equation solving problem, a equals 7, b equals 30, c equals 23. Plugging it in, we get negative 30 plus or minus the square root. 30 squared is 900 minus 4 times 7 times 23. And that's all going to be over 2 times 7. Evaluating this, x equals negative 30 plus or minus 900 minus 4 times 7 times 23 is 256 all over 14. I can write this as negative 30 plus or minus 16 all over 14. At this point, this would be an acceptable answer, even if it's not reduced. Moving on to the next problem. Based on the rational root theorem, you need to make some good guesses for what could be factors. I'm going to take 32 and list all the positive and negative factors of 32. So that's going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, and plus or minus 32. Those are the only possible rational roots of this quadratic polynomial. In terms of how many roots, I look at the degree of my polynomial. There are 4 possible roots. Okay, what I might do to try to set this up is use synthetic division. So I'm going to put my coefficients 1, negative 1, negative 18, 16, and 32. And any of the numbers that I chose as my possible roots could work. I'm going to start, I don't know, with 2, which I know means x minus 2. Okay, for synthetic division, you bring the 1 down. 2 times 1 is 2. Neg 1 plus 2 is 1. 2 times 1 is 2. Neg 18 plus 2 is negative 16. 2 times negative 16 is negative 32. Bring down to negative 16 times 2 gives me negative 32, which is 0. On the first try, we get one that works, which is really nice. That means we have x minus 2. We're going to reduce each of these powers by 1. So instead of x to the 4th, it's going to be 1x to the 3rd plus 1x squared minus 16x minus 16. Here's the other nice thing that happens. If I look back at my possible roots, could I ever guess 32 anymore? Probably not, because now my last number is 16. So 32 no longer makes sense as a possible factor of that. Okay? I guess 2. That seemed to work. Maybe I'll guess negative 2. And I'm going to take what is left over instead of starting over again. So 1, 1, negative 16, negative 16. I did 2 last time. This time I'll do negative 2.
Wait, do you have to do negative 2?
You do not have to do negative 2. You can do any of the other ones that you'd like.
Okay.
I just chose to do negative 2. Negative 2 times 1 is negative 2. That brings me down to negative 1. Negative 2 times negative 1 is positive 2, which brings me to negative 14. Negative 2 times negative 14 is positive 28. That one does not work. I can cross out negative 2 as a possibility. I'll never have to try that one again. I'm just going to go down and try a different number. Maybe 4.
Are you picking from the ones over on that side?
I'm picking from the ones on the left side.
But if you got 0 for 2, that's okay, right?
If you got 0 for positive 2, we did get 0 for positive 2.
Yeah. You have to find all of them.
You have to find all of them.
Oh, really?
Yes, this is completely factor.
Like every single, like.
So 1, 1, negative 16, negative 16. Bring down the 1. I get a 4. 1 plus 4 is 5. 4 times 5 is 20. I end up with 4. 4 times 4 is positive 16. I get 0. We know that meant x minus 4. Here's what we have so far. We have x minus 2, that was our first factor. X minus 4 is our second factor. I had an x cubed, now I've got a 1x squared plus 5x plus 4. Once you get to this point, you don't need to use synthetic division anymore. We know how to factor quadratics like x squared plus 5x plus 4. Our answer is going to be x minus 2 times x minus 4. X squared plus 5x plus 4 factors into x plus 4 and x plus 1. That's the top half of this problem. The bottom, identifying the zeros, is a matter of taking the numbers you have in parentheses and seeing what would make them 0. The zeros would be 2, positive 4, negative 4, and negative 1. That would be a full answer to this problem. Here's a screenshot that you can use of the last page.